Okay, just wait for me. Okay. Một phép nói chuyện.
Rồi, mở cái này nha.
Rồi, một phép nói chuyện.
Ok, ok, ok.
Okay, last time we already talking about common emitter amplifier. Remember what? Okay, common emitter that telling you emitter will be routed in AC. Okay, and if you're looking on this circuitry here, basically they draw DC. That normally you will see. So you get a sideways. Only 10 millivolt IMF applied to the common emitter. So what I like you, when you see the circuitry, you have to recognize common emitter or common base or common collector. Therefore, bipolar transistor. Okay, how do we recognize this is a common emitter? Easy to do. Make sure the input apply to the base, okay, and output from collector. That is a common emitter. And a common emitter, this is your input sideway, and this is your output sideway. So basically, you can see the input and the output will be our phase. 180 degrees different. Okay, that is you need to know. Second thing, what the name for capacitor C1 and the purpose for this C1. And we already telling you, C1 is DC blocking or AC coupling. That will be telling you the input coming in and the DC will be blocking. This is your void right here. You don't want to emphasize your void including DC. So that's why this capacitor will be block any DC from the input, but they will be let AC coming into the base. Okay, so at the base, you will be get two signal. If you're looking on the scope, you can see the DC voltage VB and also this side wave. Okay, second thing, capacitor. It is the bypass capacitor. What they mean for bypass? Bypass what? Basically, you get a sine wave at the base, and at this point also you get a sine wave. Same thing. However, capacitor will be shorted for AC, so that's why current IE for AC they short to round. So when you measure at this point, you only see the DC. You cannot see any sine wave. The thing is they short it to round. So that's what they call a bypass. Now, they can ask you bypass what? What they bypass? The answer will be, for AC, they will be bypass RE. Okay? That means AC cannot go through RE. They short here to the round. Okay? So that's why they call it bypass. Okay? When you measure at collector here, you can get two signals. One will be DC, collector voltage, and also the sine wave. And that sine wave will be opposite to the input, look like that one here. Okay? So, at the collector, you get also DC and AC. At the capacitor C3, that same thing. DC block or AC coupling. The thing is coming out here, you get a load here. The load here basically, that will be the speaker. So they don't want any DC going to the speaker. Okay? They allow only AC. So that's why they need that capacitor. They will be block the VC collector voltage DC. Okay? And only the sine wave will be coming out. And this will be displayed the sine wave at the output. Okay? So that is telling you everything related into the common head meter. So you get any question, anything? Okay. If not, that's what we call a VB. That A and that C. Common collector, common admitter, common base. So now I get a question. If I want to calculate the VB, telling me the formula, how do I get VB? What I would like you guys to do, you have to tell me quickly. Okay? That look like I don't know how to do. You tell me. What VB equal?
Okay, point 7.
I said formula. We don't do calculation.
Wasn't it a VCC times R1 over R1 plus R2, something like that?
Perfect. VCC. Okay. Time R2. Divide R1 plus R2. We just want the formula. If you get a formula and you still cannot calculation, you better quit. Cannot training for you guys to be a technician. A very, very basic thing. We have to get through it. Okay? And now telling me VE. What VE equal?
VV minus 0.6.
What minus 0.6? You understand it, a diode will be turn it on. And you get a plot here. 0.7. VE. That means the voltage from head meter to the ground. VB, the voltage from the base to the ground. So VE equal VB. Minus 0.7. And another calculation we want to know, VC. What VC equal? The thing is, next time I want to make sure when I ask you the formula, you have to carry me right away. Okay? That will be VCC minus I see. I see. You get that? Okay. If I want to calculate the IE, what IE equal?
1 plus beta times
No,
IB.
no. Right now, you cannot using that formula. You know that the VE right here. Okay, you get VE already. Here. If I want IE, law. Right? You take the VE divide to RE. That one you get IE. And if I want to calculate the IB, the formula will be IE divide 1 plus beta. And if you want the IC, beta times IB. And finally, I want you to tell me R prime E. What the formula and what is the R prime E? R prime E will be equal to 25 millivolt divided to IE.
Question, Mr. Pham.
Yeah.
I was wondering, like for IC, I know you got beta times IB, but for IC, can you subtract IB from IE and still get IC?
Okay, we can do that way. However, what they let you know, IB will be very small. So that's why they don't want to using IB equal IE minus IC or
You
IC
mean
equal IE minus IB. That's what they want you to do using the formula we given to you here. The thing is the IB are very small. So they're not really easy to do calculation. If you're using IC equal IE minus IB and look like IB, IC and IE almost the same, the thing IB too small.
okay?
So that's what I asking you to using the formula we given to you here. You can do that way, the other way, but I say that is not a good way.
In the industry that you work in, is that like an approximation?
Normally in industry, the same thing. We engineer, we have to do this way. Okay? So if you want to do your calculation, you have to do using the same way. But what I'm telling you, at work, normally you don't have to do any calculation. When you check the circuitry you measure somewhere, they engineer already telling you what they want. How many ampere or milliampere or voltage or millivoltage, whatever. They're telling you you don't have to do calculation. I can give you an example. When they telling you, okay, they want to measure voltage, VB. Okay, so you can see VB, V lowercase letter. That means AC voltage. The big thing is how can you using the scope to measure that AC?
The in.
So when you using the scope, okay, and you can see the voltage that will be here, you will see how they look like. That's a 0 volt here. However, that's a DC voltage. If we calculate, we can see 12 times 6.8 divide 6.8 plus 22. Who get the value? Give it to me. What the value? How many volt DC? This 2.8 volt.
2.8.
Okay, what I'm saying is when you in the Zoom, you have to working with me.
I got
If you want-
2.83.
Yeah, that's okay. If you want me still giving lecture for you, I don't want to telling, you just sit there and watch. Okay. So basically when you measure the voltage at B and they display to you 2.8 volt DC. And now 10 millivolt I am at. look like they look like that one. And you cannot measure that sideways. The thing is, DC voltage is too big. So just telling me, what can we do? Set up in your oscilloscope. When you're using your oscilloscope, the scope using in the class, then you have to, first thing what you need to do, you have to set it up. First window for channel 1, second window for channel 2, next one channel, second window for channel 1, next will be channel 2 and channel 2. That is the first thing you have to set that. Then the second thing, you have to set the first window to measure the V peak to peak. Second window measure the frequency. And for channel 2, you have to do the same thing. That's the second thing you have to get through. Next thing, you have to make sure your scope probe, they have to be matching. If you using 1/8, then the both have to be 1/8. Or if you using 2/8, both have to be 10/8. Okay? They have to be matching. That's the minimum thing you have to do before you can go to do anything else. Also, by the way, you see that display for oscilloscope. How many divisions from the bottom to the top? How many? You know how many?
I think there's 6. No, take that back.
How about 8?
8.
Yeah, 8.
8 divisions. To measure the voltage, right? All right. Okay. Now, when you measure to set your voltage, I said 5 volts per division. Total, how many voltage? How many volts?
5 times 8 is
5 times 8.
equal 40.
40 volts. Maximum you can measure is 40 volts. Okay. Now, if you get 10 volts, per division, then you can time 8, you get 80 volts. Maximum you can get only 40. And now they go up to 80 volts. That's why you set the the scope drop into by 10. By 10, that means 8 division. They times 10. So you can measure up to 80 divisions. You can see that. That is why I'm telling you when you do your left volt, they're telling you set the scope to by 10. You don't have to. If you know how to using the scope, we don't care about that. Any voltage, less than 40 volt, then you can set to by 1. Only thing the voltage when it's too big, then you have to set it by 10. But the left volt, they're using the analog scope. Okay? That means the old scope 15 years ago or 20 years ago. We're using a better scope. They can do much, much better if you know how to use it. But that's what I'm telling you. When you're working on oscilloscope, in this case, you want to measure that small signal here. Very important thing you must be memorize. Set the scope to AC coupling. When you set AC coupling, and this will be 0 here, and now you can see the sideway. They try to block 2.8 volt, no more. That's how you can measure.
Hey, Mr. Pham,
Any question? Anything?
yeah, Mr. Pham, on AC coupling, is that the one where you can see AC and DC, or is it DC coupling? Where you can-
AC coupling, only AC.
Okay, so AC coupling, you can see AC and DC.
No. DC coupling, you can see both.
That's what I wanted to know. Thank you, thank you.
So that's why you want to see the AC coupling. They block that DC. So now you can see the sine wave will be bigger, you can measure. Okay? This is a very, very important circuitry. I try to go over it. Make sure you're able to understand, you can follow it. That is what I need you to memorize. Okay, so now you quickly try to get to on up this calculation for me. Okay, we already did it, okay? Now, this is AC module, okay? So that's why AC, you see that? Meter connect to the rack. That in AC, okay? And if they draw this way, it not make sense to me. Right here, they put a DC. Basically, any DC voltage in AC, they must be ground. That's what we already talking last time. Okay, and now they given to you all of the formula. You want to calculate the R prime E. R prime E here. That means the resistor from the base to the ammeter. In the DC, from the base to the ammeter, you get the diode. However, in AC, no more diode. It's substituted by R prime E. And that will be calculated by this formula here. 25 millivolt divided IE. Okay. That's just a formula. How do we calculate it? Now, R in base. What that mean, R in base? That means if you're looking from the source in here, that's right here, the source. You're looking into the amplifier. That's what they get the R in total. Or they call a G. Either way. That means from the source you're looking into the amplifier, you get the resistance. That's what are in total. Okay? And R in base, that means if you're looking into the base here, okay, you can see what the resistance. So that's why R in base will be RE at the base. They already calculate for you here. Okay? R in base, you want to calculate it. Take a beta times R prime E. And R in total, that including R1 parallel R2 parallel R in base. Okay? If you want to calculate the RC output, then RC will be RC parallel to RL. And if you want to calculate the gate, they will be RC over R prime E. Okay? And if you calculate the V out, you take the AV times V input. Okay, now we will go to common collector. Okay, general. They say you can see that the same as what they call a meter follower. So common collector, they get two names. One they call a common collector. Another name will be meter follower. And you know the collector ESAC round. That's what the common collector. Common meter. That means meter AC round. Common base. The base is at the AC round. It's a stable voltage gate. High input impedance. low distortion. That means less noise. Okay. So basically, you can get the common emitter. Okay. Common collector. That is out here. But the important in here, high input impedance. You can see the gain for the common collector will be very small. They almost the same at the input. Okay. However, the benefit for the common collector is the high input impedance. If you're looking into the amplifier, you get G in. G in, that means input resistance, and they will be high. That's only telling you. When you connect anything into the common collector, okay, you don't want the signal will be lost. Okay, that's why you want the input impedance will be high. If the input impedance low, so they will be pulling it down. The signal coming in. Okay. And also input output will be in phase. Okay. That is the characteristic for the common collector. Now we will see how they connect. You can see very simple. When you look into the circuitry, you know that will be common collector. Input apply to the base. There's the input here. However, output will be coming out from emitter. Okay, so you know that will be the base. That will be collector. That will be emitter. So basically, VFE and V out, the same thing. Okay, that's why they call a emitter for follower. That means output following the emitter. So when we see the circuitry input applied to the base, output from emitter, that will be common emitter or emitter follower. Capacity 1, same thing, DC blocking or AC coupling. C2, also DC blocking, AC coupling. The thing is, you know, emitter here, you can get both DC and AC. However, go to the output, here, speaker right here. You don't want any DC. So that's why we need C2 to block any DC from admitter. Okay. Input look like, output look like. They in phase. Okay. And also almost the same. That means the gain is not much. The benefit they're using this common collector. Very important thing is input impedance will be higher. So if the signal coming into the base and you don't want that to be lost, you need the high impedance. Okay. And you can come in and the output the same thing. Input, output, the same signal. How do we need the amplifier? Okay. The reason we need it, the thing we want, input impedance here will be higher, so they're not loading down the signal. That's it. Is that a general about common collector? Any question? Get any question? Anything? Anything in here, we already telling you. Input apply to the base, output from admitter, C1, C2, DC blocking, or AC coupling. Input, output will be in phase. That's the only thing I want to make sure. Okay? You're able to memorize those and make sure also input impedance will be high. Now, this is the AC module. You can say you didn't see any DC voltage here. Okay? You see that right here. DC will be ground for AC. So that's why you never see any DC in the AC module. Okay? This is the base. This is R prime E. That means admitter right here. Okay, in the AC, same thing. From the base to the admitter, you get the resistance R prime E. And that equals 25 millivolt divided IE for bipolar. Okay. In the DC between the base and the admitter again, there will be a diode. That means 0.7 volt. However, for AC module, you don't have any more diode. They substitute by this resistance. Okay, at the admitter, you can get here. One go IC go this way, IC go the other way. Okay, so that's why that the IE and also that also coming out here. You get RL. That be out. Now, when you're looking into the base, we're looking for input in impedance. Okay? and they already calculate to you in here. R in base. That means from the base, okay, to the round. You can calculate R in base equal beta times R prime E plus RE. Okay. R in base equal beta times RE. R in total. That means you're looking from here to go into the base. You can get R1 parallel with R2 and parallel R in base. Okay, so that's why they give it to you here. R in total. R1 parallel R2 parallel R in base. Okay. That is we're talking about G in. When we're talking about AC, you get G in, then you have to know what G out. G out. That means from the output, okay, you're looking into the amplifier. That's what you get, what they call G out. Okay, some textbook they using this way. Okay, RC. Try to see the difference. If they using RC, what that means? That means the admitter at the collector. If they're using a small RC, that's the same thing with G out. AC resistance. So now, if you're looking from G out to the circuitry, what you can see? I can tell you, they say this resistance and this resistance, they in parallel. So that's why they do calculation for you right here. RE, that means G out equal RE parallel with RL. Okay. And if you calculate the gain, voltage gain, they given you that is the voltage gain. Okay. Equal RE divide R prime E plus RE. If you get the gain, you want to calculate the V out. You take the input times the gain. Okay, I want you to do this calculation for me. From A to K. Go ahead and do it. Okay, what the VB equal?
5.
How many volt?
5.
5 volt.
Okay, 5 volt. So that will be 4 point
1.3.
perfect. 4.3. That will be equal
4.3 milliamp.
perfect. VC, same thing with VCC. VCE will be equal VC minus VE. Okay. 10 minus 4.3.
5.7 volts.
Perfect. 5.7 volt. R prime E 25 milli divide 4.3.
8.33.
25 divide 4.3. You get 5.8, right?
Yes, sir.
Oh. Output impedance 1 volt times 1 volt divide 1K times 1K divide 2K. Look like 0.5, right?
Yep.
KO. R in base beta times RE 175 times 0.5. You get 87.5.
87.5. Yeah.
Okay. R in total. That means R1 parallel R2 parallel R in base. You just do calculation for me.
Is that like 8.16?
You say 8.16 kilo.
Right. Right, kilo.
Anyone else get the same? Let me know.
Yes, 8.16.
Okay, perfect. AV. What the gain equal?
Is it 0.98?
0.98.
I think so.
Okay, someone get 0 point. Anyone get close to that value? Let me know.
Yes, sir. It's 0.98.
Okay.
Point 9885.
Okay, that's perfect. That's only telling you the gain very close to 1. Right? That's one thing. Input, output, almost the same. Okay?
So are you saying unity gain or something?
Yeah. Close to that. They don't have a big gain like common admitter. If we want the more gain, then we have to using common admitter, not common collector. However, if I want high input impedance, then I using common collector. Okay? VL equal 0.98. Ah, 1 volt. Okay, so you can get whatever you get. Take your calculation. Okay, so for you guys, when you're looking into the circuit, and you know this is a common collector or admitter follower. Okay, and what the C1 doing, C2 doing, okay, and any more calculations, then you need to get the formula, okay? But what I'm saying is, if you go to the college, then you have to go detail. But this program training just technician for 1 year. We cannot go too much detail. Why at work, really you don't have to do any calculation. Or if you have to do, you can open the textbook, anything, to get the formula. So that's why the handout will be help you a lot. For anyone later on, if you want to do calculation, then you can easy to find out the way to get through it. Okay, the last one for bipolar transistor. Okay, that will be common base. And when you reading, it says the base is at AC round. Okay, the input drive the ammeter and the output is taken from collector. No current gate, but had a high voltage gate, low input impedance, high output impedance, and they will be using for high frequency application. That basically summarize for the common base. Try to keep reading over. So whenever they're talking about common base amplifier, then you can talk. Okay? And on of this amplifier, you will be working on that volt. Okay? The common base, okay? You can see input now applied to ammeter. Right here. This is common, this is collector. This will be the base. Okay? Input here. Now they apply to ammeter. And output will be from collector. Okay? That is, you know, this is a common base. Okay? Now, what is C2? What's the name of C2? You understand the VB, right? You can get a DC. VB. VCC. Time R2. Divide R1. That we're using all the time. That means at the base here.
Hey, Mr. Pham, you asked for the name of what?
C2.
Oh, C2, you mean like the coupling capacitor? DC blocking?
Okay. DC blocking. AC coupling.
Coupling.
Okay. Now, why do we need that C2 in this position? Why we need here C2? Who can explain to me?
You don't want the AC signal to go to ground.
Well, common base amplifiers are common to the ground, so that's how you connect the base to the ground, and you have to have the coupler.
Common base. Okay, common base, you know, AC they will be routed. Correct?
Yep.
But the thing is, I want to know, if you don't have a C2 here, what happened?
The signal that comes in goes to ground. It doesn't go all the way through to where the output would be at.
That's not quite.
Not quite.
Yeah. I asking you, if I don't have a C2 here, what happened?
TP to go to the ground.
B will be go round. Correct?
Yep.
That means the transistor cannot work it. The DC at this point, they will be go to round. You see that? Without the C2 here, DC at the bay will be go to the round. Capacitor transistor not working. So that's why they need C2. For the DC, they open. Okay? They open. That means the voltage DC cannot go to the round. They will be AC, they will be go to the round, but not DC. That's the reason why we need C2. When you measure at the B here, you get 0 volts. Something must be wrong with the C2. They short it. So that's why they go to the round. Okay? C1, this is your input here. Apply to ammeter. C1 will be DC blocking AC coupling. Okay? At the collector output here, same thing. C3 will be DC blocking AC coupling. Okay? So if you're looking at the input side wave, output the same phase, same side wave, but they get a gain, so they get a bigger. That's what they already explained to you in here. No current gain, but have high voltage gain. So that's why you can see the output will be bigger. So I hope when you're looking into the circuitry, okay, and you know that will be common base. Also, that will be help you when you do the left volt on common base. You know how to make the connection in the circuitry to make it to be common base. And in here, they just given you voltage gain. This is the formula. Input resistance, output resistance. C1 and C2 is DC blocking. So basically, you get 3 amplifiers for bipolar. When you understand a little more on this bipolar transistor amplifier, common ammeter, common collector, common base, that will be more easy for you when we go up to the J FET. That's another transistor. Field effect transistor. Also, they can be amplified. They can be common short, common drain. Okay, that means the same tree. Same like bipolar. Okay. Okay, this is the last one. I want you to do calculation for me. Okay. And make sure you need to download in the comment in the handout, okay, for the next meeting. That's what we're talking about, differential amplifier and operational amplifier. Okay, so who get the VB?
One point 76.
7.6, 7.6,
1.76.
1.76. If you get a different, let me know. Okay,
1.06.
VB 1.76 minus 0.7.
1.06.
1.
06.
IE. That means 1.06 divide 1. K. 1.06
Kilo.
milliamp. You have to get the IB and you have to get the IC. What IB you get?
Four point 22 microamp.
Okay, IB very small. 0.004 milliamp. Okay, so what we see equal? That equal 10 minus 1.2. À, 2.2. Okay. Okay, so I given you on of the formula. So if you get the time, you have to go through it. Okay. Now summarize. This is the CE amplifier. They summarize everything you need to know. Okay, for common F meter. The next for the formula, common F meter. Okay, and this is the AC module. Whatever AC calculation they will be given you in this summary. CC amplifier. They're telling you what you need to know. And this is the formula, okay, for CC amplifier. And the last one, CB amplifier. Okay, that's just a summary on the formula and the general thing you need to know. This is the last one. They call Darlington connection. They connect the transistor second one to 8 meter on the first one. That's only telling you one thing. If you get a beta 1 for the first one, the gain beta 2, the gain for the second one, and the total gain equal beta 1 times beta 2. That's only telling you if beta 1 100, beta 200, you get a gain up to 1,000. Okay? That only I try to make sure you understand when you're working with this kind of circuitry. Okay? Have to be very, very careful. For some reason, this is short to the round, they cook right away. The thing is they get a high current. In the left one, I think you will be working on. And this is another way, Darlington transistor. They put 2 transistors inside one packet. Okay? Darlington transistors are manufactured with a transistor in one case. Okay? That means this is together Darlington transistor, but inside one case. They can connect by separately. Okay? So that is whatever we already done for bipolar transistor. Next meeting, we can telling you, we can connect that one CE amplifier to another CE amplifier or another one. Okay? Then you can see a little more. However, make sure you have to know how the CE amplifier working. What relation between input and output. That will be help a lot when we combine. Okay? Any question? Anything?
Hey, Mr. Pham, I got a different question.
Yeah.
What day and time do you lecture Tech 2?
Take you on Tuesday in class,
Oh, okay.
5 o'clock.
All right, thank you.
Yeah. The thing is, take you still need to talk to me, see me. Cannot be in the Zoom until
Okay.
I feel they know what's going on. Okay?
Thank you.
No problem. Okay, so good night.
Good
Mr.
night.
Pham,
Good
Good
night.
night.
Thank you.
Good night, sir.
Night.
Have a
Mr.
good
Pham?
weekend.
You too, sir.
Mr.